So let me start that. You currently hold the George Ellery Hale Professorship at Caltech. So could you please tell us who is he and what is the connection with that chair particularly?
Okay. So at the beginning of the last century, the biggest telescopes were in Europe, actually, um, which is not a great site for optical astronomy, but that's where the countries were. And they had small telescopes in like Argentina and South Africa for survey work. Uh, However, by the beginning of the last century, the U.S. became quite, you know, rose, and their the initial telescopes are the Yerkes. In fact, that was the biggest telescope, uh, near Chicago, of the University of Chicago, and the at the Lick Observatory near San Jose on the west coast. Um, There's a young person then called George Ellery Hale, who grew up in Chicago, and he really was fascinated with astronomy and wanted to build big telescopes, but on the west coast of the United States, which in generally the west coast of the Americas, so in the northern part of the west coast in California, and then especially the counterpart is also west coast in South America, Chile. Those are the very good sites. But he had found already one of the best sites was in actually the mountains overlooking the city of Los Angeles. And he grew up in a rich family, so he was got his PhD from Chicago and was able to get money, a substantial amount of money, even in those days, uh, to build the 16-inch telescope at Mount Wilson, which is the mountaintop overlooking the San Gabriel mountain range in Southern California, where the site quality is very, very good until the city developed and the light, but quality-wise, it's good. Okay, which turned out to be a big success. And he was able to raise money for a 100-inch telescope, which was a spectacular success. The 100-inch is when astronomers realized the expansion of the universe, the true size of the galaxy, um, using Cepheid variables and novae, um, and sort of really spectroscopy because it had a large collecting area. However, this was done in collaboration with the Carnegie Institution, which had in fact, they had the technology in Pasadena. They're still there. It's called the Carnegie Observatories. For the 200-inch telescope, Hale really thought it is important to have a program with have it based in a university, not a pure observatory. So there was no Caltech then. So I'm talking of like 1910, 1915 of that in that era. So he persuaded. He was an amazing guy. I don't know how much energy he had, but he persuaded an a local polytechnic school, where uh, uh, quote unquote men were taught carpentry and women sewing, um, to recast themselves as a research university. And that was the birth of California Institute of Technology. In fact, right next to Caltech, there is still the old Polytechnic, but that's now a school rather than a. And the Rockefeller Found, he was able to persuade the Rockefeller Foundation to give $9 million, I can't remember now, in 1928 or 29, um, just before the big crash. And fortunately had the money, and so it was gifted to Caltech. And so Hale started build 60-inch Mount Wilson, 100-inch, got the 200-inch project funded, started Caltech. He started the Astrophysical Journal, maybe even the National Research what is now called the National Research Council. Um, he was a discoverer of magnetism in the sun. Um, if you come to Caltech campus, there's a big bust of him because he managed to then recruit Millikan from Chicago to be the first president, then Robert Noyes from MIT, eminent chemist of his era, to be a provost. And so it's hard to imagine that this small institute in a small town suburb of Los Angeles is now such a powerhouse from 1920 to whatever. Yeah, so soon I don't. They may have a different starting point for exactly when Caltech begins, but this is about 100 years old, and so the president of our university, when a donor gave a lot of money for some years ago, and they decided to make a chair sort of the highest level, and the president thought I should be the inaugural chairholder. So I've been George Ellery Hale professor, so I don't know, maybe 2017 or 16, something of that sort.
4 or 5 years.
Yeah.
So these observations are done before Hubble's observation of galaxies.
No, Hubble is the one who used the 100-inch telescope.
Oh, okay,
Yeah.
okay.
All the work done by Hubble, Bardet, Minkowski, Zwicky, a lot of that stuff it's all the 100-inch and 200-inch. Sorry, 100-inch and 60-inch.
I see. Okay. Yeah, I was just trying to find the connection there.
Yeah. So Hubble was a staff astronomer at the Carnegie Observatories, which is about 3 miles away from Caltech. So when 200-inch was built, it was jointly operated both by Carnegie Observatories and Caltech.
So now, next, I want to ask that you were born in Kurundua in Maharashtra.
Yeah.
And how was your life at that time growing up in India? And were you interested from your childhood pursuing, like knowing more about natural science and pursuing career in natural science at that time?
Yeah. So I was born in a very small town, barely town, called Kurundwad. But my parents stayed there only for a few weeks, and because my father was a government doctor, so he got transferred. And I grew up largely in Hubli, in the city of Hubli in northern Karnataka. Did all my schooling there, more or less. And then after that, I went to IIT Delhi to do a integrated program where you do both BSc and MSc in one go. From there, I went to University of California, Berkeley for my PhD in astronomy. And from Berkeley, I went to Caltech, where I've been there for 36 years. As a child, it was clear to me I was mainly interested in sort of, let's say, the physical sciences. I had a lot of fascination for for mathematics, but I just liked it. It just seemed very neat. But I realized I didn't have any special talent in that field. But I read like Scientific American in the university's library, and roughly I knew I wanted to do research and not go into industry or be a doctor or lawyer or engineer, which is sort of the more traditional paths.
And you did your PhD at University of California, Berkeley. So what did you work on at that time?
For my PhD in Berkeley, I was basically specialized in radio astronomy. I had an exceptional advisor who understood what I really wanted to do, and it was somewhat of an unusual PhD. In a PhD, you normally choose a topic. You say how galaxies work, how stars work, something. But I wanted to basically learn all the tools of radio astronomy. And that's because I have a very peculiar view for, at least in astronomy, my view is that it's primarily phenomenological science where you have to go and observe nature. and that nature is actually much more imaginative than you are, and much so. I don't buy into the idea that you ask a question. Okay, it's good in some subjects. You ask the question and you try to answer. That's my view is that astronomy is so it's so rich because the universe is very big. It's been around for a very long time, and it has 10 to the 11 galaxies, and each galaxy has 10 to the 11 stars. So the number of possibilities in the universe is extremely large. So my view for astronomy, anyway, and I don't want to say this for other subjects, is it's like you walk into a, let's say you go to Brazil, the Amazon, which is very, you know, teeming with all sorts of plants and flowers and animals and insects, and you take a camera and you just study, and there'll be so much. Then you start understanding what is the pattern, how are these things. So I strongly believe in using nature to guide our understanding, and not an bottom up, which is I ask questions. How did the universe begin? Because I think without that guidance, you'll be wasting time, because our imagination is faulty. So some people will think something will think something else, and whereas if you start with data, then your thinking is more directed. So my thesis was more is like learn all tools of radio astronomy, and then once you learn the tools, you just point telescope anywhere and you learn something. So I strongly believe in the statement that if you look at something for a few minutes, anything, you'll find it's very interesting. And the universe is highly connected. I don't mean in a deep spiritual sense. If you understand, for example, lamp shift in the laboratory, it'll have some impact in the universe somewhere. Okay, so physics and astronomy and mathematics, which is a tool that allows us to do analysis, it's all very strongly linked, and they're all fascinating. So it's not like, oh, this is more fascinating than the other. They may not be important. I'm not sure. I'm much into the saying things should be important. Um, um, yeah.
Great. So who was your role model in your childhood or even now, whom you follow?
I don't know. I know there's a theory of role model and so on. You have to understand, even as a child, I was very confident of myself. I'm very uh, secure in who I am, both not in a negative way, which is, oh my God, I don't know who I am, or in a positive direction, which is, oh, I'm really great. Nothing, I think so. I don't have a strong, I don't actually, I personally have not been in the role model view, if at all. So I didn't have anyone, I would say, but I had, what should I say, negative role models. That is who I didn't want to be. Okay. I felt growing up in India, much of the science and our choices that scientists in India made was theoretical astronomy, theoretical physics, mathematics. Okay, and I think that's a very strong cultural choice. Um, and I have a very strong view that the Asian countries made a wrong cultural choice by going in for these sorts of essentially ranging from cultural to religious ideas on what is important. Now, Europe made a bad choice too. For a long time, Christianity had a huge hold on inquiry. Galileo's story is a famous one. But I think the question you should ask is, why is it that the Asian countries, even when they had so much, they were at times, and the GDP of apparently India and China exceeded everything else and so on, why didn't they progress science-wise? And my view is that the Asian countries, and now let me focus on India in particular, there's too much value given to theoretical inquiry. Okay. So I didn't, believe it or not, to me, Chandrasekhar was not my role model. And because if you read his book on stellar astronomy, he gives lemmas and theorems for stars. No, I'm sorry, but stars are not mathematical objects. Okay, you may model a star with a differential equation, and differential equations have certain rules, but a star is not eventually captured by a differential equation because it's not a mathematically, it's a much richer thing, and it's very dirty. It doesn't, to first approximation, you can say a star is round, and so you can get some theorems from that. But a star is actually not round. It'll have convection cells, it may have rotation, it may have magnetic field. So um, I didn't want to be a theorist. This I knew very strongly, that no matter what it is, I'll be an experimentalist, uh, modeler, but not a theorist. And I think that's a big weakness that even today in India people have. They know some of string theory is one of the most theoretical subjects in physics, and of course there are many string theorists in the US and Europe and so on. But one of the countries which has a large number of fairly high quality string theorists, both in quality and quantity, is India. Okay, now that's a bit odd if you think about it, because if you ask an observational astronomy, are we there? No. So that's a cultural choice. Okay, and if you ask a question like, we can form what I call the Olympic index. Okay, so let's give a gold medal as 10, silver 5 points, and bronze 1 point. Okay, you, and at the end of the Olympics you add up the score, and then you divide by the population. And if you want to show India and Romania at the same time, you have to use a log scale because they differ by many orders of magnitude. I think that's, again, this is a cultural choice. Okay, so I think for me, being connected to reality is extremely important, and theory, in my view, is simply a crutch. You make approximations. The amazing thing is, by assuming stars are round, using basic nuclear physics, you can understand a lot. Not 100%, but you can get maybe 90% right away, which is the amazing thing. But mathematics is not going to replace understanding. It's, in my opinion, it's a tool to convert the physical laws into computational things. I know this is a contrary view. Anyway, so you asked me for advice for the Indian kids. I said, forget this. Don't be influenced by the usual stuff of, trying to be theoretical in the choice. Your own state, I think there's too much emphasis. Bengalis all want to do, mostly want to do. And I don't think it has gotten the Asian countries very well. So, at least India.
Yes, I mean, now the question comes that how long one should or the government should support theories. For example, let's take an example of string theory. Like how long we should work on it, but we cannot have evidences to prove it that if it is wrong or right.
No, I don't go so much into specifically string theory and so on. That's a bit, how to put it, it's not that important in the long run. Uh, I'm talking for a bigger issue. I think countries and societies um, should have a full approach to life. So you may say, why do we need to have art and music and art? And okay, I don't know, but somehow it is important to have this for the full development of ourselves. So it's very hard to take one thing and justify it. Okay, so if you ask the Taliban in Afghanistan, they'll say we shouldn't have music, we shouldn't have sculpture. Okay, there are religions where any representation is bad. Okay, so I think those are they are wrong ideas. I think we as humans have amazingly enough all sorts of things, and a good society would support them. Okay, and uh, there is no immediate benefit of supporting singing, but many of us derive quite happiness just by hearing singing, and some derive more happiness by singing it. Okay, in the same way for painting and so on. And same thing with science. It's a more of a brain activity, but it generates a lot of understanding, which actually, spin-offs of science are now very well known. We are no longer disputing, is science necessary for survival? The answer is absolutely yes. Okay, so what I'm saying is, it's not in India they shouldn't support string theory. I think My view is that government of India is actually exceedingly helpful to the scientists. They've started many institutions. They have reasonable funding suited to the, they could increase that, no question, in terms of percentage GDP. And I think it is still not at the sort of the standard OECD level or something. But I think the spirit is there to support. But young people would want to say, I want to do experimental science, I want to do modeling, I want, but the overwhelming thing is in India, the brightest students typically want to do theory. And I think they're missing the opportunity because each of us has strengths, and not all, we should use what is our strength, not what we want to be.
Yes, I mean, following this, like not directly related, but how do you think about the pseudoscience culture, which is, I think it is present in every culture, but nowadays, in my opinion, that we try to justify some of the scientific achievements through the lens of religious, religious identities or dogma, I'll say. So what do you think that how we can fight against this pseudoscience culture?
Well, uh, you, I've thought a lot about sort of, this is now, you, there's pseudoscience, there's religion, and there's science, okay? But let me address even the most direct one, which is simply religion, okay? Um, my view is, and again, I have a strong view here, it's fine. Some people want comfort in life, they want assurance. To the extent if they go and do rituals and they follow this, if they have going to the church every Sunday and listen to something and partake in that, if it makes them happy, it's fine. I'm indifferent to that personally. I mean, if you do it, why should I object to that, right? It's only when you want to thrust it down other people's throats, or when you claim this is it, then it becomes bad. And religion has always lost that. The Catholic Church was very powerful in the previous millennium, right? I mean, the Pope held so much sway in Europe, I'm saying. Okay, and they took great scientists like Galileo and said, okay, you're heresy, so you can't speak about this. But they lost. So there's no time any religion has actually won against reality. When religions are forced to face reality, they've always lost and will continue to lose because they're nothing to do with the real universe, the real world. They're, in my view, they're poor ideas of that somehow have exponentially grown. Okay, they're inconsistent with each other, and I think my view is that the very fact we have so many religious people um, is not very different from pseudoscience. What's the difference? One says, ah, yeah, then God is there up there doing these things. Then someone else is saying something else. Qualitatively, they're in the same league. And so you have to conclude from this, most humans have a very simple view of the universe. Maybe they're unable to accept the more analytical view that there are 10 to the 11 stars in a galaxy, there are 10 to the 11 galaxies, that means 10 to the 22. If most stars have a planetary system, that's 10 to the 22 planets. Okay. And even if 1 in 1,000, okay, let's make it 1 in 1 billion supports life at any given time. Okay, we're looking at 10 to the 22 times 10 to the minus 9. Okay, that's 10 to the 13, right? And if each of those guys have their own half a dozen religions, each claiming the original stuff, it really is ridiculous if you think about it. But for some people, maybe it's too frightening to see a sort of a thing it's working without any design, and I don't get it. Okay, it's that sort of feeling. So they want to go and take up religion. I say fine for that, but I think there's no simple way out of this. Humanity will go through um, periodically through foolishness of denying reality. They'll create religion. They'll create political thought. So, for example, in the Soviet Union, there's Sortinian did very well in mathematics, in physics, um, okay in chemistry, and very badly in biology. Do you know why? Because there's a communist Politburo member, Lysenko, I think was his name, was a biologist, and he had some weird ideas about biology. And he made that as a it that is in Sortinian you have to sort of accept his view of biology, which is flawed. Of course, it failed. So it's just unfortunate because of people's sort of lack of rationality. We just have to go through this.
Exactly. So to sum up this segment, just I want to ask one simple question. Do you believe in God, or do you believe in we are living in a simulation that somebody is controlling us, some superpower?
No,
I know this
I
question,
don't. I
but
don't.
many people ask it.
I don't really. My view is that if you don't understand something, you can't immediately say, "I know the answer." That's sort of being very. I would say this is sort of, to me, it's a simple thing. If 1,000 years ago, when if there's or 2,000 years ago in Hinduism, for example, you have God for wind, you have God for lightning, okay, so on and so forth. Okay, that makes sense. Thousands of years ago, we didn't really understand. But we understand wind now. We understand lightning. There's a current, there's charging up, and so on. So those gods have now slowly, as you understand, gods melt. Okay, so um, I honestly don't even understand why would someone start off by saying, "Oh my God, I look around here, and therefore I don't understand. Therefore there is God." It's an amazing. I would say I would call it as intellectual laziness. Instead of trying to actually understand, you're basically throwing in the towel and saying, "There is this supreme person who has spent all this time devising this thing," and then they'll say, "God, help me, be kind to me." I was thinking, well, if this God has actually created you and so on, why is this God giving you so much trouble and so on? It seems a rather incomplete God.
Yes, it makes sense to me. At least I think in the same way. So now let's just talk more into the scientific topics.
Yeah.
So what are your current research interests and what you are currently working on?
Well, I sort of I'll preface by saying about every 5 to 10 years I switch topics. So my current interest is literally less than a year old now. Um, and I'm now interested in studying the matter between stars, interstellar medium, um, and it's a big part of our ecological system of our galaxy. You have stars. Stars are made of gas. Then there's gas between the stars, and so in some parts of the galaxy, the gas condenses, makes new stars. Everywhere in the galaxy, or here and there, stars are dying, and when they die, the more massive stars explode, and they return back the gas to the galaxy. But this time, they add every star is like a nuclear fusion reactor. It's making new elements. So when they return back, it's called enrich. So they add what astronomers call metals. So you'll get more carbon, nitrogen, oxygen, magnesium, silicon, maybe iron, and then you get the next generation of stars. And stars, we now know all stars basically. The way you make stars has through be what's called a protoplanetary disk. That is the conduit, and therefore all stars by the time they're born, they will have planets around them. A whole planetary system, in fact, just like the solar system. So the interstellar medium is like the common meeting thing between star death, star birth, and all that. That's my current focus.
And what are the unsolved problems you want to get answers in your lifetime? It may not be necessarily from your field particularly, but in general in astronomy.
Yeah, I know. This is something that, how to put it. I understand that there's a very popular view. There are big questions, and it'd be nice to ask. Yeah, okay, so I can come up with a standard list. What's inside a black hole? Okay. What is the end of the fate of the universe? What is before the Big Bang? What is the nature of dark matter? What is the nature of dark energy? Okay. Um, and then more equally interesting question, is life really common in the universe? Uh, is it possible that out of the 10 to the 22 planetary systems we have, that there's only one planet, Earth, which has, you know, intelligent life, or life which actually can start modifying the surroundings and start thinking and observing? Or are there lots of them? If so, you know, um, it's very curious that sitting here we can actually start understanding the rest of the universe. I find that the most astonishing thing, actually. But those are all fine. But I sort of, that's why I told you I don't buy into this top down. I'm a simpler scientist. Okay, I don't have a. Uh, I'm more interested in the inquiry rather than what I'm inquiring about. Okay, so that's the reason I changed fields, is because I want to develop myself, learn new things, apply, find some interesting stuff. Repeat that. Okay, so I don't have a strong. I want to discover, some really. I want to answer a. I want to answer a grand question. Okay, um, and I make no excuses for that.
Okay, that's great. So, I mean, following this, I would like to ask that you have contributed in many different fields. Now, according to you, what is your most like significant contributions, which if you have to judge your research career?
Well, I would say no, I won't judge. The reason is there's no value in that sort of a judgment. Let's say you have three children, then I'll come and say, which of those is your most favorite one? Well, if you have any sense, you will not tell me the answer, okay, for many practical reasons. But even if you did, what is the point? It's, how to put it? I honestly don't. Uh, the word is not the problem with the English language is the negative words are too negative. If I say I don't care, it sounds very harsh. But honestly, I don't care in a simple sense. I'm indifferent. Again, it's negative, but I wish there was in English language a word which is like times zero multiply a word. Okay, so if you say, okay, Shri, we are recognizing you for this, 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 I honestly don't care what your list is. Okay, so I sort of don't find much. Mm, I don't see a strong reason to actually rank order. Let me tell you why. In my first year in grad school, no, when I was finishing up my undergrad, we had a support thesis project. I built a machine, okay, and I slaved away in the last 2 months, more or less 18 hours a day to finish it before I was going to graduate. And finally, it worked. I felt a fantastic thrill personally, which was perhaps one of the biggest thrills I've felt in my life. Okay. Then in first year in grad school, I wrote a paper, which is a paper, maybe it's got 30 citations. It's a technical paper. Uh, and when solved that and wrote it, I was pretty happy actually. For a month, I was like, wow, I was so happy. And then end of my grad school, I discovered the first millisecond pulsar. That's when I lived in Arecibo, Puerto Rico. And that was a big discovery. I mean, I didn't know in immediately, but I knew I discovered something big, or not big, something new, totally new. No one had heard of millisecond pulsar, and as it turned out later, so I had a lot of thrill. And in between, I had a lot of thrill when I came up with a new method for a very large array in New Mexico. But recently, just what 2 years ago, there's a project I had conceived. There's a grad student working on it. I gave it to a grad student and said, okay, everyone, there's a big effort worldwide, tens of millions of dollars, big, facilities, and we had $400,000, small grad student, a faculty member, and an engineer. And we discovered at the same time a very bright burst from a magnet in our galaxy, which showed at the same time as a bigger facility, which showed that magnetars are the origin of FRPs, at least for a good fraction of them. It's a big discovery. Okay, Nature paper, press, and all that. But when he told me it was fine, but here I am. I'm 40 years later. So the thing is, what are very relative in your mind at that time. Okay, but for the world, they don't care what happened. So you can rank order by simple things like citations, and but how does it help? So my view is that you should only judge something if there's some value to it. And many times, many of these things have no value at all.
So you have supervised many PhD students
Yes.
and more than 50 postdocs, and I am sure that you have many collaborators around the globe.
Yeah.
But have you ever failed in doing something or get frustrated working on some problem? And how do you deal with it? Because all PhD students, we often encounter frustration and we try to think that how to come up. So
Yeah, no, that's a good, practical question. Yeah, I have failed. It's sort of easy to remember. Well, one of the ones which, the penalty was very high. I mean, failures where you work for a month and then you discover you made a mistake or this effect goes away. That's, quite common. But as a grad student, when it happens, it's very disconcerting. So a lot of those things you just get better by being more critical in thinking and double checking and so on. But there will inevitably a failure. In fact, I would say, I always tell my students, uh, you should have failures early in life because the only way I'm convinced now most people learn is through failure. I think nature has built us to be optimistic. Okay, so let me tell you exactly what I mean by that. So let's say you finished a paper and it's a good paper and you submit, it's accepted, you feel very good. And then the other one is, let's say you worked hard on a paper, you submitted, and the day you submit, you see another paper, not exactly the same, but almost overlapping. Okay, then you feel little. You say, if only I'd submitted a week before, month before, one day before, who knows? Okay, but the way most of us interpret it is the following: "I'm so unlucky, I got that." But when everything happens routinely, you don't say, you know what? I was so lucky. So we think whenever good things happen, it is because we deserve it. When bad things happen, it's either bad luck and this and so on. So the only way you learn that sort of stuff is if you have a real failure, it's unambiguous. It'll force you to think what went wrong. Okay. And this I can tell you, most people lack the ability to step outside themselves and see who they are. And it must be something very deeply built into the way nature has designed us. I think if we judge ourselves too harshly, we won't progress. Okay, if we think too, uh, if we think, if we are not very hopeful, sometimes we lose out. So let me give you an example. Let's say your plane is flying, uh, and you're watching the some big desert, okay, and it goes down, and okay, not and then somehow you're there, and you just have one bottle of water, and before it went down, you knew the map, okay, and in the desert is 1,000 miles away, right in the center. There's no town, nothing. You know this, okay. Let's say there's another person who didn't know, was sleeping throughout. Suddenly his plane is down. Okay, he doesn't know this, so he'll say, okay, he'll choose something, okay, some direction. He'll start walking. Uh, Now you know that there is nothing here, so you'll be completely convinced, not convinced. You'll say, oh well, I'm dead. Okay, so you lose all hope. But just say it so happens that this person who walked to the north actually come across a party which is doing some desert tour as it happens, completely accidental. So he's rescued. Whereas you, who's convinced that there is no hope, you'll die. So I think um, the lesson of this is you have to learn to be optimistic, okay? Because many times survival is actually very uncertain. I don't mean now give you a silly example of surviving in the desert, but survival could be just in ordinary life. Getting a job, not getting a job, well, that is survival in a certain way. So you have to be optimistic, but you should at the same time be able to say where you're doing things wrongly, where can you improve, what is the cause of your failure, what are your weaknesses. They're opposite. Optimistic means you don't want to look at all the weaknesses. If you look at the weaknesses, you might, like this guy who didn't move much from the plane, you may not move anywhere and get something. So the main advice I would give to young people is, what I used to do, not do it much less now, is end of the day, especially when you're young, you should always review, said, okay, the day is finished. What things did I do wrong today? Wrong, I don't mean morally or something, where maybe you spend a lot of time doing a calculation, okay, when it was not necessary. You got 90% of the effect done, but you loved it, okay. Fine, there's nothing wrong. You can analyze and understand that. Or you spoke to someone to make a joke, but it was not. In retrospect, you realize, oh well, this can be misunderstood. Sort of a self-analysis. If you can do that, you'll progress tremendously, because the point in life is to understand your weaknesses and make sure that that is not on your path, okay, of success, and to understand your strengths and to make sure it is on the path, okay. So, for example, as I told you, when I was young, I loved mathematics. And when I went to college, I did find some other people. They seemed just more gifted at mathematics than I was. I mean, they just seemed to have an ease. Okay, as you know, IITs are very hard places to get in, so you get a lot of talented people. Um, so I knew, this is not my strength, even though I like it. So many young people make a mistake. They say, "Oh, I'm very interested in quantizing gravity, and they want to work on that." But for every job, there are some skills you need. As it now stands to quantize gravity, you have to know quantum mechanics very well. You have to know gravity, GR very well, okay? And don't know, no one's found a simple way. They're extremely mathematical subjects. You have to know tensor algebra very well, differential equations, so many things. If you can't do that, at least as we understand, you shouldn't be doing quantizing gravity. But many people are driven by the question and don't ask the hard question, do I have what it takes to do this problem? So I advise I give to my students very simple. Never do research unless you have an unfair advantage in that area. Okay, so yeah, that's the advice I would give.
Could you please elaborate a bit what do you mean by unfair advantage?
What means where I'm better, okay, because it's not like research is immediately competitive, but it is competitive. For every faculty job, place like Cornell, there'll be 100 of well-qualified people, let alone the number of applications. If maybe the number of applications will be smaller because people say, it's too high place, I don't have a choice. But I can assure you, for every position in a quality university, there are like a long line of very qualified people, right? So in that sense, it is competitive. If I get a job, you won't, but it's not immediately competitive with you. So in order to be in research, you do need a home, you need a supporting institution, you need grants, and you need the intellectual company, meaning a part of a department where you can talk to people. And therefore, you have to shine. It's not like just saying, oh, I'm interested in research, support me. It doesn't work that way. Why should we pick you and not the other person? Well, the only reason to pick you is you're more qualified. So you have to, if you want to be in research, you have to succeed at a very high level. And how are you going to do that? And the way you're going to do that is you ask good questions, but you should be able to find answers to them in a finite time. And so if you're not talented for whatever reason, either by lack of training or lack of your brain, I have no idea. And I don't want to say, I strongly believe you can train yourself into many, many things. Okay. There's a so-called 10,000 hour story, which is if you put 10,000 hours into something, you become an expert. So if you do 10,000 hours of piano playing, it's a what's called an urban legend. I don't know if this is true, but there's in fact a book on this. 10,000 hours, you're a piano player. 10,000 hours, you're a tennis player, and so on. But I think there are somewhere, I think even 10,000 hours later, someone like me, I think I'll be very, I probably could do some GR or some quantum mechanics 10,000 hours later, but it probably won't be so great. It's my judgment. So all I'm saying is, if you have some strengths, you should know what your strengths are and what your weaknesses are. Play on your strength or what your weaknesses. But I think many young people, they're fascinated by the question so much that they'll say, I'll be into quantizing gravity, come high, hello, high. Well, fine, okay, it's a risk you take. If you do it, good for you. Chances are unlikely.
Yes, I agree.
And also, I think, in fact, this is where the role model theory is, in fact, not wrong, but is almost fatal. Many times, many young people say, "Oh, Einstein, like fantastic guy. Einstein was amazing." Okay, I really don't even understand how this brain even worked. Okay, but I would simply not use Einstein as a role model because this is so much the exception. Okay, so some say, oh, he sat down, thought through special relativity, being a patent office clerk, and he sat down. So in effect, they're saying, oh, maybe if I do some deep contemplative. I think that's a bad idea. In fact, Einstein, the best role model is the model closest to you. Okay, so you should never choose a role model of some big Nobel laureate person because they're usually very exceptional people. And so the best role model is someone who sort of is like you, a little ahead, and from them you learn what mistakes you could be making, what are possible, and so on. So I actually think this role model theory is in fact wrong, and that's why I don't have role models. What I do is I analyze people continuously. When I was young, I would always analyze what is the reason, what is the strength of this professor, how do they think that is different than mine, and then incorporate it into my thinking.
Yeah, I never thought about it in this way. Actually, it's a very new philosophical thought that we actually really probably don't need to follow exceptionally talented role model because we always.
Yeah, so many times I teach a class to students where it's sort of like a or sort of life and career sort of thing, just to some once a year, not a class, but a thing with students. I sit down and say, okay, I've been around, I'll help you, or just give you my thoughts. And uh, you then, this is the tragedy of if kids who grow up in poor countries, there are no local role models, meaning some local professor who's doing nice research, publishing, teaching. Whereas a kid growing up in Cornell, right, can come here from some school trip, see a professor, who's done some nice work in the Cornell newspaper, and he can say, maybe with some work I can be him. But if you're growing up in India, you don't go to any of these places because it's not well set up. Your role model then tends to become an Einstein, a Chandrasekhar, which are actually the least plausible role models. So I start my class by saying, if your name is fine enough for me, please, you can leave the room because you don't need any advice from me.
So as we are running out of time, I'll ask last one
Yeah.
question that what do you like and dislike about Indian educational system, and if you are in power to make some changes in educational system, what changes you would like to see or implement in next 10 years or 20 years?
Um, well, the things to add are really, to emphasize the wholesome part of development. So, sports and music and arts, they're all important, okay? And we tend to focus only on the academic side, which is okay. I mean, that is the basic thing. I mean, I'm for example, like Cornell is a great university, but has I think some football team, or maybe it doesn't. I don't know. It has all these other teams, which I think is silly. Okay, I mean, but at a school level, I think we should. It's important for us to develop. Okay, but it's hard for me to tell you why, but I'm not convinced that a wholesome education must include other expressions than this. I don't have anything big to offer. If you want to, point of education is to make you think. So rote memorization and this sort of stuff is not very good. Just approach for thinking, and that. But I would say that's a problem that is there not just in India. It's also in Japan. I know because my wife is from Japan, so I'm very familiar with the Japanese system. Don't know much about China. Yeah, so a real good teaching should make people think. Should supply them the joy of nature, and the beauty of mathematics. That sort of stuff.
That's great. So this is really last question, and it's a very simple that many people ask, like successful people like you. So do you aspire getting some recognition for your contribution in science, for example, Nobel Prize? Because everybody asks that to you.
Okay.
So what is your take on it?
Yeah, my view is that the only value of a prize for me, okay, it's got money, it's great. Then I can, I want to rebuild my house, so I get the money. I told my wife, get a prize, we'll get because we want to do. Okay, that's the big obvious, right? No, it's how to put it. The main value of a prize for me is, and I've gotten a few prizes, and the main value is that it opens the doors. So if you have a big prize and you write an NSF proposal, they'll take you more seriously, meaning they'll. Okay, so when I was 35, I got NSF's highest award. It's called the Waterman Prize. It's given to one person in the United States across anything NSF does, and engineering, biology, medicine, physical sciences. Okay, so of course it's crapshoot. Okay, who's going to get that, right? But then that year, I wrote a proposal for NSF. Of course, they're not going to turn me down, right, for the next 5 years. So I said, yeah. So that, of course, I got the money. That's what I'm saying. The point of a prize is it opens doors. And then, you can call up you can call up someone, yeah, I'm a Nobel laureate. Everyone will say, yeah, you better listen. Even if you're the same person with and without Nobel Prize will have more, open, the doors are there. So I see the practical value. But if you really believe in the whole 10 to the 22 stars and exoplanets and all that, okay, the 10 to the 13 we concluded worst case scenario. Okay, let's say there are a billion people in each of them. That's 10 to the 22, back to 10 to the 22 people. You think your Nobel Prize means something? Okay. Yeah, so I don't get that actually, because, if you go to an old monument or old fort or a palace in Europe or in India and something, you realize, this person was great. And you look at the whole broken stuff. So this is it's really a bit silly if you think about it.
Yeah.
Okay.
Thank you very much. Thank you very much for your time. It was my pleasure.